everybody that's listening, everybody that's watching, welcome. And I am the Postgres consultant out of the professional services group. And in these days of COVID, I know a lot of people are suffering and having difficulties, and I wish everybody well. Interesting thing about open source. When things are good, you're busy. When things are bad, you're even busier. And things are very, very busy here at Percona. So much so that we're looking for another Postgres consultant. So if you're nice and you'd like to relieve some of my work pressure, please reach out to us. Tell us about yourself. And continuing from there, I am now going to share my screen and do my little talk. And next slide. Good. Thank you. Nope. Back, please.
Oh, sorry.
There we go. All right. So we have about 30 minutes. What I'm trying to do is to tell you about a real case study that took place some time ago. And this talk was originally based on 3 hours, full of details, full of conversation, a lot of back and forth between the people who were listening and I was speaking. So it's a bit of a challenge to compress it down. If you are involved in doing migrations, please take note because this is real stuff. This is the real technical information. It's a high overview on how to do it. Next slide, please. So the thing about moving data, migrating from SQL Server over to Postgres, let's go through the simplified approach. First thing you need to recognize is the foreign data wrapper. In this particular case, there's a foreign data wrapper called TDS_foreign data wrapper. You identify the foreign tables, the connection information that you're going to do. You create your foreign tables, and you copy the data from the foreign tables into Postgres. That's the simple high overview step. Lots of details in between. Migration isn't complicated. What it is, it's a lot of steps of little things. It's tracking all these little activities that can trip somebody up. Next slide, please. So in this particular case, we were working with anything with the Postgres version 9.6 and greater. So we had to design our target database on Postgres. What's it going to look like? What do you have to do to make it work so that it's going to be able to migrate successfully? SQL Server works on the concept of schemas. Postgres works on the concept of schemas. So we try to match them in as well. We also need additional information. You notice on the slide here, I have on the 4th point, identify system catalogs and tables of interest. It's not just the data. It's the data about the data. We need the definitions. How are the tables constructed? What is the order of the columns? Where are the foreign keys? What are the constraints? Where are the views? What are the codes and the instructions inside the sprocs and the function calls? So we're dealing with functions, tables, constraints, primary key, foreign key, check constraints, views, triggers. Then after you identify all these, then you go into your function, your sprocs. You install, once you've identified all these issues, then you're ready to install your foreign data wrapper. Then from there, get your connection info, you create your foreign table, you populate the table, you apply the constraints, you process the triggers, then you process the views. Now, populating the table is actually, it seems to be a straightforward thing. But in our particular case, we had an issue. We actually had to deal with encoding issues. Microsoft has their own standard of encoding, and there were coding corruptions. So we had to figure out how to deal with that. There were pieces of data that weren't working out. The constraints. The constraints is an acid test. When you apply the constraints correctly after the data is in place, if the data is wrong, you want to know. The constraints, by applying it, you catch it. The triggers themselves, they're standard operation. You have a table, you want post-processing, you want updates, you want special information or processes to be decided by virtue of the triggers. When you're going from SQL Server over to Postgres, let's acknowledge the obvious. The code isn't going to be the same. So what do? You disable the triggers. You create a shell of the triggers, and at a later point, then you address. What you want to do is just define the steps. Are the triggers in place? Will the triggers fire for certain operations? That's what you want to test out. The views themselves, the environment, the client that I'd worked with had a SQL Server system that had been in for many years and had been taken care of by many people. Now, there's two ways of using a database with intelligence when it comes to report generation. One, the dominant popular way right now is where you have application servers that take the raw data, they munge it, they create the reports, and they present it. But then there's the traditional way, the way that has been used historically in SQL Server, in Oracle, not so much in the open source databases, because the modern way, the more advanced ways, are always being adapted first in the open source approach. So what we had were views that would actually generate the reports. You just read the views and out come the reports. But challenge was over time, these views didn't get dropped, they didn't get updated, they created new ones. So you would have the first generation of views would be based on tables, then the second generation of tables of views would be based on tables and views. And then over time, these views would become more complicated, more convoluted. So how do you migrate views over from SQL Server over to Postgres with that kind of a history? The solution actually is pretty straightforward. You create the views, you get the codes, you define them, and then you just run the instruction in Postgres. When it fails, you have a dependency issue. Fine. Run the script, you cycle it, then you run it again. If you've done everything right, over time, every time you cycle over and over, creating and processing the views, the number of views that are left out are going to be smaller and smaller and smaller. And finally, you'll either, under ideal conditions, have no more views, or you're going to have a couple, which means there's something wrong. There's something inside the definition that you need to look at. Next slide, please.
I've given you remote control, so you should be able to click yourself to the next slide.
Okay. How do I do that? How do I do remote control here?
There you go.
That one?
Yeah.
Cool. I learned a new thing. Okay. As the title says, here's the secret sauce. I'm giving credit where credit is due. Postgres has always, in principle, always been compliant ISO ANSI standard. Microsoft also has been doing it. Without Microsoft being ISO compliant, ANSI compliant, we wouldn't have been able to do it as easily and as simply as we could. The reason is the information schema. Postgres has, by tradition, PG catalog schemas, the metadata, the data describing the data. Well, in SQL Server, you have sys schemas that have the same information, but the ANSI standard is the information schema, and the information schema is consistent between Postgres and SQL Server. You can actually look at the table definitions in an information schema in Postgres, and you will find the same definitions, the same description of the columns. They're located in the same order. Now, there are differences, and we're going to go through how to deal with that. When you look at the importation of functions and sprocs, understand that when we did the import, that has to be considered a separate exercise. It's tedious work. What you want to do is get the skeleton of the function and the sprocs over, just so that it can compile, just so that it can be put into Postgres. Then the actual exercise of refactoring it, you'll be in a position to do that. In our case, we had two teams. One, perform the migration. Two, refactor the functions. When you do this, in our particular environment, we didn't use a Windows environment. We went straight to Linux. We had Linux workstations because we wanted conformity as closely as possible to what the server was going to be. So when you do it, you can generate the system and you create an environment, a build environment that can cycle break up these steps into modules, and then you're going to find out there's a lot of mistakes, a lot of things that are going wrong. So you just make your little changes over and over and over. The last step, a very important step, this is your validation. Get yourself a command line interface for your for your SQL Server. And in this particular case, Microsoft was very good. We had recently become aware of that when they put in the Azure cloud for a SQL Server, they made command line clients, and those clients fitted nicely on our Linux box. So we were able to test, validate, even double check on the constructions of the various tables and check out our connectivity. And let's go to the next slide. Did I do that? No, I made that smaller, wrong one. Oh, here we go. There we go. Being a Postgres DBA, I did all my reference information, all my decision making using the Postgres references. It is bar none the best referencing for any database system out there. When you look at the system catalogs on the left panel, the equivalent is on the information schema on the right panel. The right panel, that is what SQL Server also honors. They will have the same types of tables with the same kind of information. Keep in mind, it isn't all the time one-to-one. When I was doing the migration, there were discrepancies. Using the command line interface, I was able to query SQL Server and find out where those discrepancies were. This is the page. Again, it's a bit dated. It's probably changed since then. Again, because we were on a Linux environment, it made it especially easy. Just downloaded and installed it, tested the connection, made sure that we were able to do everything properly. Okay, so this is the complicated part. You're going to break down and you're going to organize your Postgres database. You need to break down into various schemas. Now, public default, which you always find in Postgres, that was going to be the first schema where anything ad hoc tables, functions, etc. we're going to go. DBO schema. This is just a copy. It's a default of the SQL Server. It's for consistency, prevent confusions. And now we've got these other schemas. These are going to be information schemas, and they're going to be foreign tables. There's two classes of these schemas. One is you're getting foreign tables in, and the foreign tables are going to be two types. You're going to get foreign tables of information schema, the actual metadata, and then there's the actual tables from the SQL Server that you want to migrate. In this example, you can see the organization on the left panel, MSSQL, information schema, MSSQL. What we want to do is when we do the migration, when we do the refactoring, we want to offload all the necessary metadata, all the necessary information, copy it into Postgres, get it there, and detach it from the SQL Server. Make it simple. We want to get away from the connectivity with SQL Server because it adds another level of complexity. So you copy, using the foreign tables, you copy the metadata, and you copy the imported tables. That's what run was. Run information schema and run. Finally, the last schema was views, and that was regenerating the views, and that was the iterative process of building and refactoring the views in real time. Once you've got the copies of the metadata, once you've got the actual data in place, you can forget about SQL Server. From here on in, you're just working in the Postgres environment, and you can work in a Linux format. Oops, let's see. Okay, so the next step is the obvious. Let's install Postgres. So in this particular case, it was a version of Ubuntu. We installed the keys. Now, all this documentation is already listed in the Postgres download page. We're just reiterating it. And look at the bottom line. We want the server development libraries because we're going to compile an extension. The SQL Server extension doesn't come, at the time that this was done, it didn't come as a pre-made extension for a particular version of Postgres. So it had to be compiled. when we created the environment, now a lot of people are used to the idea of using virtual machines. In this particular case, I wanted to test the network environment, so I used Linux containers. By creating a container of a particular version of Ubuntu, I was able to replicate and put everything that I needed. Okay, so here's the information about creating the foreign data wrapper. Again, this information may be dated, you may have to update it. What I like about the Ubuntu distribution, it's a Debian derivative. All the libraries that you need, they're going to be there. Sometimes the other distributions, they don't have it there. It doesn't matter if your final target is Red Hat, or if it's something else, or if it's CentOS. By putting it on Ubuntu, you make it easier for yourself to get the libraries prepared. Transferring it over is pretty mechanical once you've already got a working version of Postgres. So as you can see, these instructions here, again, they're published. All you need to do is to locate the GitHub, and you'll find the same instructions, up to date, of course, and you'll be able to replicate and create the extension. So we need to test our connectivity. We've got the extension in place. We check it out. Of course, what's not written here on the slides is using the SQL Server command line interface. We use that to verify our ports, our usernames, our databases, our passwords. Once we've confirmed it, we replicate it here in the foreign tables. Again, you can see here, here's our foreign, the implementation of importing foreign tables, which is really nice when you do a schema because it's a one-off. It was very useful in our case because we had several hundred relations. I had just short of 100 tables and several hundred views. Doing this replication, this manner of importing the foreign tables made it a lot easier. Okay, now issues. So let's go to the point where we've installed. We've gotten the foreign tables. We are importing the data. We're copying the data into the tables. We've succeeded. So what about everything else? Data types, operators, function overloadings. When you write it out, again, you're now going to create this Linux development lifecycle environment. So you need an environment that's going to be able to be easy to read, easy to understand. You're going to deal with check constraints. When you create function calls, the practice that I've always used is use the in and out arguments. It's clear, especially it's important because I wasn't familiar with SQL Server as well as I am with Postgres. So you want things as clear as possible. Explicitly say, where's your in arguments? Where's your out arguments? Because when in doubt, you can ask somebody else and they read your code and they understand it better. One of the things to keep in mind, the functionality of the code, the instructions, they're not going to be one-to-one mapping. Don't worry about it. Comment them out. Put them in as a reference. You don't want them active. All you want is the shell. Okay. So Postgres is amazingly flexible. It can do operator overloading. It can do function overloading. It can mimic a database system. The question is, do you want to do that? In order to do the migration, do you want to save yourself time by just creating the same symbols and operators that SQL Server uses? Or do you want to take the time to refactor the code? That's a judgment call. It is a judgment call. You're going to have to decide on your own. The way we did it was we broke it up into modules and activities. So we actually did do an overload, but in the long term, we removed the SQL Server behavior that we were emulating with the operator and overload in order to have a more consistent Postgres interface. Keep in mind, once the system is up and alive, you may walk away from it. There may be other people that's going to maintain it. Don't presume that they're going to have the same knowledge set as you. So converting, editing, overloading, there's all sorts of tricks. This is Linuxy stuff. Sed, grep, awk. When I was working with the views, the function calls, the regex matches, those were great functions. They allowed me to change things. The code that was being migrated was actually pretty consistent. So it was possible to do a pretty good job of changing things out. If you're really fancy, if you're a Linux guru, you could even go old school and use scanners, Lex, Flex, Yak, Bison, etc., etc. So here we go. In the particulars, what are you looking at when you have to deal with conversion considerations? Check constraints. Check them out. Queries. Sometimes the queries are going to be written a little differently. That's what you're going to have to reconvert, massage. You're going to find the bulk of your work in doing conversions, this first pass of migration, getting it on Postgres, just getting it there successfully, is going to be dealing with the views. In terms of functions, you can see the examples: date part, date add, date diff, function overload. We had to emulate the functions. I didn't want to rewrite it inside the functions. There were several hundred of them in these views and the function calls. So I just created the functions. It made it easier to see what was happening. Is null versus coalesce. That's a big issue here in SQL Server because it has intrinsically different behavior. Is null on SQL Server is different than is null on Postgres, vice versa with coalesce. Operators, take a look at the example. The double pipe for concatenation of Postgres, that's not what's used in SQL Server. It uses the plus. Money conversions, Postgres, SQL Server. Again, there were these little issues. Triggers, again, they were other issues, more complicated. This is where we shorten things up. What I'm doing here is in the 3-hour presentation, we went through the actual code, and it was actually some really quite fun looking at the instructions. It was all written in Bash, but we're just going to look at the overview of the scripts themselves because, again, we are reiterating the steps. So the first thing was, okay, create the foreign tables. Remember, break all this down into modules. It's just easier to figure things out. Watch out for the casting data types. Watch out for SQL Server's column and table mixed case names. When creating the foreign tables, they were mixed, but when they were copied over as tables in Postgres, when the data was copied, the tables were explicitly lowercase to follow normal standard Postgres convention. Now, it is true that when you work from GUI clients interacting with Postgres, you can do mixed case, but in our case, we just preferred lowercase. It just made things for us, because we were working on the command line, a lot easier, more straightforward. The next script, populate the tables. Now, the population, actually, it was remarkably slow sometimes. It's the nature of the beast. It's one of the reasons why we wanted to disconnect from SQL Server as quickly as possible. The foreign data wrapper took its time to translate and populate the tables. They did populate. It was like several hundred gigabytes large, the entire data set. It took time. Constraints. This was a fun part. We had to go into the meta tables in SQL Server to identify all the constraints. We needed to compose the queries. This particular script that we're reading, that I'm using as reference, actually queried the constraints in order and rebuilt them and reconstituted them on the Postgres side. It listed all the tables. It identified the columns, the table constraints. What we've got here are the actual tables, the meta tables that we need. So as I said at the beginning, we copied everything. The foreign tables, in this case, we copied the meta table, the information schema from SQL Server over to Postgres, and then we played with the data. We were able to take the information gleaned by copying the tables over and creating proper function migrations to be able to reconstitute and recreate it. This took time. It was actually quite complicated and detailed, and it was fun. There's a little comment here on this screen. You see where it says beware of MS catalogs, 2 kilobytes? There was one view that we had that was about 6 or 7 kilobytes large. Now in Postgres, that was no problem for the information schema view, but there was actually a 2 kilobyte limit. It truncated the view in the information schema in SQL Server. I was forced to go to the sys objects. and read the information from there and copy it over. Beware and remember that command line interface going to SQL Server, it helped. It helps a lot. Populating the tables, the information schema. Once we have the tables, the schema information, we copy it over, get it over so we can work with it. Now we're ready to add primary keys, add foreign keys, and we're reading the metadata and we're applying them. Primary keys first, then we did the foreign keys. Everything works, it just finishes. When you have inconsistencies, that's when you find out, not just with your constraints, but data corruption issues. The trigger list. This is where we had to, I cheated. I went to Google. There was a nice old SQL Server copy and paste about how to get the triggers, and we were able to output it out. Don't be afraid to Google this stuff. As well, if you want, I can take the steps, reach out to us, and I'll see about getting copies of these shell scripts available to you. Lifecycle, add the views, regenerate, get problem views. Linux does standard error, standard output. Standard error was great. Anytime there was a screw up in the cycling, it just made a list and I reviewed it. I ran script 08A over and over again until I had a limited number of views left. And then from there, I examined what the nature of the errors were. There were many issues. It's the development environment that makes the difference. Get everything set up, get everything over from SQL Server, and you're good to go. And I thank you. And I think I made it in 3 minutes. So don't forget, we have October, we have our Percona Online.